Okay, so these are our last solving equations notes. At the top, you'll see your title already written for you. Equations, identities, and in parentheses it says all real numbers because that's what an identity is when your solution is all real numbers. And then it says contradictions. That's just another word for when you have no solution. So I'll be using identities, all real numbers, contradictions, and no solution in all that vocabulary in the video today. So it says listed below are some of the definitions that are needed to have a complete understanding of types of equations that are in this course. So we're kind of bringing all of our knowledge about solving equations together. So it says an equation is a statement that two expressions are equal. Well, we know what expressions are. So I'm just going to give you an example. Remember, expressions are basically an equation without an equal sign. So there's one expression. And I'm going to give you a second expression. So that's 3x plus 7. This is 2x plus 4. And basically, an equation is saying that these two expressions are equal. So you just put an equal sign in between them, and we have an equation. Now, this is an equation with variables on both sides of the equal sign. A solution is a replacement for that variable that makes the equation true. So basically, what number can we put in for x to make this equation true? Well, that's basically solving the equation. So if I try this out, 3x plus 7 equals 2x plus 4, and I'm solving, I minus 2x from both sides. I get x plus 7 equals 4. Minus 7 minus 7, I get x equals negative 3. Well, my solution, so the solution is x equals negative 3. So it's basically whatever x equals or whatever variable. And it says it's the replacement for the variable that makes the equation true. Well, that's just like checking it. So if we do our check over here, we do 3 times negative 3. We're just substituting negative 3 in. 2 times negative 3 plus 4. I'm going to separate that. 3 times negative 3 is negative 9 plus 7. 2 times negative 3 is negative 6 plus 4. This is negative 2 equals negative 2. So this made that equation true. Negative 3 makes this equation true because when you check it out, it's negative 2 equals negative 2. All right. Now an identity is an equation that is always true. So identities have all real numbers as solutions. And we've seen these, we just got introduced to these yesterday. So here's an example. Here, let's say you distribute the 3. We get 3x plus 1 equals, and on this side, we make both of these positive. So we get 2x plus 3 plus x. Well, then we combine our like terms on this side, 2x plus x, and we get 3x plus 3, and just bring this down. Then what do? We subtract from both sides our variable. This is 0, this is 0, so we get right here 3 equals 3. So all real numbers are solutions, and remember we saw this yesterday as the R with the little double leg over there. Okay, a contradiction is an equation that is always false. So a contradiction has no solution, and this is what we used yesterday, is no solution. So here's our example. Of course, we distribute the 4 first, and we get 4x minus 12 equals 4x minus 7. Then we subtract 4x from both sides. We get negative 12 equals negative 7, but it does not equal negative 7, so it's false. So there is no solution. This is a contradiction, just as it says contradiction up here. Okay. A linear equation is an equation that can be written in the form ax plus b equals c, where a can equal 0. So basically this is saying this is a number, this is a number, and this is a number. A can't equal 0. B and C are just numbers. The present of a variable inside the absolute value, which looks like this. This is what these spaces for. So if we have a variable inside absolute value signs, which are these long ones, it looks like, If we have a variable inside a radical, which is a square root sign, if we have a variable in the denominator, which is a fraction like 1 over x, or if the variable is raised to the power of anything other than 1, so that would be like x squared. So all those examples there that are in red are likely not linear. So they're likely not to have one solution, and linear equations have exactly one solution. So just keep that in mind. Equivalent equations are formed when solving equations by correctly applying properties of equality in which each successive step results in an equivalent equation. Equivalent equations have the same solution. So this would be something like x plus 2 equals 6 and x plus 3 equals 7. These are equivalent equations because the solution or the answer to both of these is x equals 4. They have the same solution, so they're equivalent equations. To determine whether a given equation is linear, an identity, or a contradiction, just solve the equation. If you get one solution, it's linear. If the variable disappears while solving so that you are left with a true statement, it is an identity, or all real numbers. Or if you are left with a false statement, it is a contradiction. So let's underline false statement, is no solution. So an example of a false statement would be like 4 equals 5 because 4 doesn't equal 5. An example of a true statement would be something like if you got 3 equals 3 or something like that. So you're going to identify the following statements as true or false. If false, state your reason. So number 1, remember, in order to identify, what do? We just solve the equation. Solve the equation. Then we're going to classify it. Okay, so we divide both sides by 3 here. We get x equals 0. Is that a contradiction? Well, no, because a contradiction says here it would end up in a false statement. So no, because that's a true statement, x could equal 0. So we know that this is this has one solution. So it's linear. Okay. Number 2, again, x plus 3 equals 0 is an identity equation. So let's see. Remember, identity means that it has true statement and you're just left with numbers at the end. Your variables disappear. So you minus 3 from both sides, we get x equals negative 3. Well, it's not an identity because an identity would be something like 3 equals 3 or 5 equals 5. So that's false. This again is one solution, so it's linear. You can just put same as above or something like that. And what I would do is cross this off and cross this off. This should be linear equation. All right, next page. Number 4. 4 plus 3x equals 10 and 3x equals 6 are equivalent equations. Well, let's solve it. We minus 4 from both sides. We get 3x equals 6. Well, isn't that the same as 3x equals 6? Yes, it is. So that is a true statement. Number 4. X plus 2 equals 3 plus x. Is that a linear equation? Linear equation, remember, is just one solution. So let's solve it. We first minus x from both sides, and we get 0. So we get 2 equals 3. Well, 2 does not equal 3, so this is not a linear equation. This is a contradiction. Contradiction. So it has no solution. This is false. All right, 5. A linear equation can have more than one solution. No, it cannot. A linear equation, if we look back up at our notes, A linear equation only gets one solution if it's linear. So let's go back down. A linear equation can have one solution. Can have one solution. So let's go ahead and cross out more than one. So that's false. An identity equation is a linear equation. Well, remember, an identity equation is all real numbers. So identity equation can't be a linear equation because identity means all real numbers and linear means one solution. Well, all real numbers is not one solution. So this is also false. And we want to put not right there. Is not a linear equation. And that's the reason why. Identity is all real numbers, linear is one solution. Okay, 2m minus 1 equals 1 minus 2m. Is that an identity equation? Well, don't get fooled here. It looks like it is, but it's actually not. So we're going to solve it first. What do? We add 2m to both sides. We get 4m minus 1 equals 1. Then we add 1 to both sides. We get 4m equals 2. In order to solve for m, we got to divide both sides by 4. So m equals 1/2. Well, that's one solution. And remember, an identity equation has all real numbers as solutions. So this is, again, false. Not an identity equation. Number 8. 2 more. 5x plus 4 equals 2x plus 2. Well, let's solve it. Is that a linear equation? Let's see. 2x plus 2, we got to distribute that. So 5x plus 4 equals 2x plus 4 plus 3x. Well, now something really interesting happens right here. 3x and 2x combined, and we get 5x plus 4 equals 5x plus 4. Oh my goodness, that equals the exact same thing. This is an identity. So it's false. It's not linear. It's an identity. All real numbers. Now, number 9, x squared plus 4x equals negative 3. They're saying that is a linear equation. Well, if we look back up here, I'm going to flip over your paper. We look back here. A linear equation can't have any of these things. It can't have this right here, absolute value, can't have x in a radical, can't have x as a denominator, and also can't have x raised to the power of anything but 1. So since this equation right here has x raised to the power of 2 or x squared, it cannot be a linear equation. That is false. All right, so we're done with that portion. These are notes that you may use on your test tomorrow or Friday, so please hang on to these. The second half of your worksheet is simply solving equations. Please check your answers with the bottom. If you look at the bottom, they have your answers there. Obviously, you need to show your work to tell me how you got them. So go ahead and start that.